Hello, this is chemistry, and we are continuing with our lesson on the particulate nature of matter. Now, last time we learned that there are three states of matter. We have the solid, the liquid, and the gas. The solids have fixed shape and volume. For the liquids, they have fixed volume, but they take the shape of their containers, and gases have no fixed shape, neither do they have fixed volume. When an object is heated or cooled, it's changing from one state to another. The change is called change of state of matter. Remember, we said that there are specific names given to these processes. From liquid to gas, we are heating. As we heat, the particles will gain energy and then escape. So evaporation is taking place. From gas to liquid, we are cooling. Condensation is taking place. From solid to gas, we're talking about sublimation. Okay, so these are just a few of the processes. I know you have the rest in mind. So let's move on to what we have for today. Now, we're going to see the effects of temperature and pressure on the motion of these particles. Now, matter is made up of particles. Matter is made up of particles. Just as these particles, when you go further, you see that matter is made up of atoms. And these atoms have electrons, protons, neutrons. We're going to talk about the structure of atoms in our later classes. But right at the moment, we need to know that matter is made up of particles. Now, once we start heating these particles, they start vibrating. These particles are already vibrating. Once we start heating them, they start vibrating faster. There's something we call the law of conservation of energy, which states that energy can neither be created nor destroyed. As we are heating, the heat is energy. So once the heat gets into the particles, they start vibrating faster. These particles will start vibrating faster. So temperature is directly proportional to the average speed of matter. So as you are heating the matter up, as you give it more heat, the vibrations become higher. As you take away heat, as you take away the energy, as you cool the matter, as you cool the substance, the vibrations go down. Okay. Now with pressure, pressure is just when the molecules in a gas hit the container. When the molecules hit the container in which they are contained, the pressure readings are recorded. Okay. Now in A, you see that these particles will have to travel longer distances before they hit their container or the walls of the container. But in B, the particles are closely packed, so they will travel shorter distances before they hit the walls of the container. So pressure in container B will be greater because the gas particles will travel shorter distances to collide with the walls of the container. Okay, so if you want to increase pressure, we normally decrease the volume. If you want to increase pressure, you decrease the volume. If you want to reduce the pressure, you increase the volume. Okay, so pressure and volume are inversely proportional. Okay, now when we say inversely proportional, it means that as one is increasing, as pressure is increasing, volume also has to decrease. As volume is increasing, pressure has to decrease. But when we say directly proportional, that means that as temperature is increasing, the average speed of the gases also increases. Okay, so as one parameter increases, the other also increases. That is what we call directly proportional. As one decreases and then the other increases, we call that inversely proportional. Now, this is a little discussion that I would like you to do. Okay, now I would like you to write something small on this. Explain what happens to the gas particles inside the balloon when the walls of the balloon below are pushed towards each other, as the hand is pushing the walls of the balloon down towards the other end. What happens to the gas particles? So pause the video here, give me the answer in the comment section, and then resume the video. Continue with the lesson. Okay, welcome back. For this, I will leave it here. We will discuss in our next class. Okay, so let's move ahead and see what we have. Now, as I said earlier, matter is made up of particles. Now, as we have our table there, if you break the table down, you're going to see that the table is going to have smaller particles that will come together to form the table. Now, these particles are in constant motion. Now, their motion do not follow any pattern. The motion of the particle does not follow any pattern. They move in a random manner. And this is what we call the Brownian motion. Okay, particles in matter move in a random manner, and this is what we call the Brownian motion. Now, this was evident when smoke particles were viewed in a microscope. Now, as the particles were viewed in a microscope, you got to see that the particles, smoke was one made up of particles. Okay, now we had the smoke. After viewing it under the microscope, it was seen that smoke is made up of particles. Secondly, these particles, the movement of these particles does not follow any pattern. Okay, they move in a random zigzag manner, and this is what we call the Brownian motion. So the Brownian motion is just the random zigzag movement of particles in matter. Okay, so please don't let this name scare you. It's just the random zigzag movement of particles in matter. Okay, let's move on to diffusion. Now, if you stand at one corner in your room and then you spray just a little amount of perfume, with time, the perfume will take over the room. The smell of the perfume will be everywhere in the room. Okay, now this is due to something we call diffusion. Now, diffusion is just the movement of particles or movement of molecules from a region where they are highly concentrated to a region where they are lowly concentrated. Now, let's look at this diagram I have here. Over here, we have our copper 2 sulfate crystal. Now, this is the region, although the copper 2 sulfate is very small, this is the region where it is highly concentrated. Okay, compared to this other end. At this place, there's no copper, so we can say there's very low concentration, or there's zero concentration because there's no copper 2 sulfate over there. But at this side, the copper 2 sulfate crystals are highly concentrated. Now, with time, diffusion will take place. The copper is going to dissolve and then spread through the test tube. Now, this is what we call the Ritter stand, and then we have the clamp here holding the test tube, which contains the copper 2 sulfate and the gel. Now, with time, you're going to see that the copper 2 sulfate will dissolve and diffuse upwards until there is an even spread. Okay, so with diffusion, the particles will keep moving until there is equilibrium, or the particles are evenly distributed. So if you spray the perfume in one end of your room, the particles will keep moving to the other end until they are evenly distributed across the room, and that is what we call diffusion. So it's just the movement of particles from one region where they are highly concentrated to another region or another place where they are lowly concentrated. Okay, so diffusion is the spread of particles from a place where they are place of high concentration to a place of low concentration, just as I stated earlier. Now, the spread depends on the size of the particles. Now, how fast the spread will move depends on the size of the particles. Now, if the particles are very large, they are going to move very slowly. But if the particles are very, very small, they are going to move very, very fast, extremely fast. So, Diffusion is the spread, but the particle size also determines how fast the spread is going to take place. Okay, so this is just a little exercise for you. Give the names of these lab apparatus. Okay, this is number 1, this is number 2, number 3, and number 4. I just want us to know our lab apparatus so that if some appear in any of our questions, we will be able to identify them. So pause the video here, give me the names of these apparatus, and then we will continue. So please write the names in the comment section below so that I can see whatever answer you're going to give me. So pause the video and do that for me. Okay, so welcome back. Let's summarize what we learned. Matter is made up of particles. Now we have 3 states of matter. We have the solid, liquid, and gas. Okay, we can change from one state to another depending on how much heat we are given or how much heat we are taking away. Now matter is made up of particles. These particles are in constant random motion called the Brownian motion. And the evidence was seen when smoke was viewed under the microscope. 1, we saw that smoke is made up of particles. 2, the particles were in constant random zigzag motion. Okay, temperature is directly proportional to the average speed of gas. And then, as I stated, directly proportional means that as temperature is increasing, the speed of the gases or the speed of the gas particles also increases. Okay, pressure of gas is created when the gas particles hit the walls of the container. And then what I said was pressure and volume are inversely proportional. As pressure increases, volume decreases. As volume increases, pressure decreases. Okay, and then diffusion is the movement of particles from one place where they are highly concentrated to a place where they are lowly concentrated. Then the rate of diffusion is affected by the size of the particles. Smaller particles travel faster than larger ones. Okay, if you have any questions, I'll be around. Please ask me those questions. Have a nice day. Bye.